We've been talking about log functions in this chapter. We're at 12.3c, and we're going to simplify a to the log base a of x and log base a of a to the x. And I have a theorem for you. And if you've missed the previous 7 videos in this chapter, you can click in the description and watch any one of those. So back in the beginning of this chapter 12 in 12.1c, we discussed this theorem. And it said for any function f whose inverse is a function, so that's the inverse of a function here, with this little -1 superscript, the inverse of the function of f of a equals a, for any a in the domain of f. And the function of the inverse of a function of a equals a, for any a in the domain of the inverse of f. And it means we know that the inverse of the function of f of x is going to equal x, and the function of the inverse of the function of x is going to equal x. So do you see how it's got this superscript, this -1 on the outside of the parentheses? It's got it on the inside of the parentheses with this f, and they're still going to equal x, all right? And that's with the appropriate restrictions on the domains of the functions, the appropriate rules that it follows, okay? So you've seen this in the last couple of videos. This y equals log base a of x is equivalent to x equals a to the y. We've talked about that. You might see a little correlation between that information in my rectangular box and what we talk about. Now, since exponential and logarithmic functions are inverses of each other, they just switch the x and y, right? That theorem applies to them. So if the function of x equals a to the x, then the inverse of the function of x equals log base a of x. So this is where you pull out your notepad and you start taking notes, all right? This is going to be important stuff because you'll be able to just follow this and plug numbers in. So we're going to let x equal a 3. Let's just say that that x is a 3. And let's say that a is a 2. So in the function of x equals 2 to the x, we'd have the function of 3 equals 2 to the third power. Well, 2 to the third power equals an 8, doesn't it? And if we put the answer 8 into the inverse function, see we've got the -1 superscript here? That inverse function of x will equal log base 2 of x. And we get the inverse function of 8 equals log base 2 of 8. Well, that equals a 3, because 2 to the third power equals 8. We evaluate the exponential function for a particular value, 3. We see how we get that value, the 3, back after applying the inverse function. This answers that basic logarithmic question of what power of 2 gave me 8? So when we see this, we ask what power of 2 gave me 8? Log base 2 of 8. What power of 2 gave me 8? 3. 2 to the third power. All right? So, keeping all this in mind, therefore, the function of the inverse of the function of x equals the function of the log base a of x. So it's saying what's inside of this parentheses is equal to what's inside of this parentheses. Do you see that? They both have the f on the outside. So what's in this parentheses is equal to what's in that parentheses. This then equals a to the log base a of x. It equals x. F of the inverse function of 8 equals f of the log base 2 of 8. See, I just put an 8 where the x is. See that? So according to this x makes it equal x. So if I put an 8 here, it should equal 8, shouldn't it? So let's see. So following this a to the log base a of x, we'd have 2 to the log base 2 of 8. And log base 2 of 8 means 2 to the x equals 8. It means what exponent is going to make this base 2 an 8? Well, it would be a 3, so x would be a 3. This means we've got 2 to the third power, which is an 8. See? If this log base 2 of 8 is our exponent, and it's a 3, then we have 2 to the third power. That means we have 8. And likewise, the inverse function of f of x equals the inverse function of a of x. That's going to equal log base a of x. That's going to give us an x. So if it says there's an inverse function of a function, then that x is going to be what it's equal to. That means if we put a 3 here, then the 3 is what it's supposed to be equal to. And it does. If we follow this as a guideline, and we put a 3 for x and a 2 for a, we're going to get log base 2 of 2 to the third power. Well, 2 to the third power equals 8. So that means we have log base 2 of 8, which is a 3. It brought us right back, didn't it? It brings us to our next theorem. So for any positive number a, where a is not equal to 1, a to the log base a of x is going to equal x for any positive number x. And log base a of a to x will equal x for any number x. That's a mouthful. So we can simplify this. It's going to equal that x. So 2 to the log base 2 of 5 is going to be a 5. 10 to the log base 10 of t is going to be the t. Log base 10 of 10 to the 5.6 is going to be 5.6. 4 to the log base 4 of 3 is going to be 3. Isn't this easy? B to the log base b of 42 is going to be 42. We just look at that. That's our answer. That's our x. See? It's a. It's going to be a. See? Now, if you're having trouble with negative exponents or rational exponents, which are decimals and fraction exponents, there's going to be links to these videos to help you out, all right? Our next video is 12.4. It's the only one for 12.4. There's no A, B, or C. We're going to talk about the basic properties of logarithms, and I have theorems for you. Several theorems. There's going to be links to the 7 previous videos for Chapter 12, and we're going to add this to the Algebra 2 playlist, and there'll be a link to that Algebra 2 playlist, too. All right? So all you have to do is click. Hopefully you're watching all the videos for Chapter 12 so you're not going to get lost, all right? I know some people make a video that's 20 to 40 minutes long. I find it easier to make the shorter videos in consecutive order so that you have time to digest what you're getting. Or you can watch that short little lesson again, all right? I'll see you next video. Bye.